All right. Well, first of all, welcome everybody to the Hatchworks AI Lab today. Excited to have you. So we're going to be chatting on AI agents, your workforce multiplier. So I'm Matt Page, head of strategy here at Hatchworks AI. I'll be kind of the MC today, and we're going to deep dive into the world of agents, what they are, why they matter, and how you can start using them to actually transform your business and just start playing around with them. These things are so new and emergent. I'm joined today by our CTO, Omar Shanti, and one of our amazing senior AI engineers, David Barrio. Welcome, guys. They're the smart folks that are going to do the really cool POC. This is, of course, a lab, so we don't just talk. We're going to show off something cool that we've built. Uh, and I know a lot of you may be here just for the giveaway, right? So if you don't know, you being here live in person, you get a chance to win a pair of Meta Ray-Ban smart glasses. Something fun we thought we'd do with this. So stick around. You have to be present to get a chance to win. Okay. So if you're not here at the end of this thing, sorry, you're out of luck. And we're just gonna do a randomized drawing. We're gonna get AI to help us out there, pick a winner. But let's add a little fun to the mix. If you comment either with an AI agent use case that you're playing with, or just an AI agent use case you have in your head, and you can use ChatGPT to help you if you want, you will get an extra entry for the drawing. And then we're going to shove all that into ChatGPT during the webinar, let AI pick out the winner of the best use case. Whoever gets the best use case, they get 5 extra entries, and we'll just do a randomized drawing at the end. So start letting us know in the comments what you're playing with, what use cases you have in mind, things like that. So there's a ton of hype right now around AI agents. Probably the most talked about thing in 2025 in the AI sphere that is massive, maybe outside of like MCP, which technically it still ties kind of into agents because it's a mechanism to make it easier to give AI and agents access to tools. And if anybody wants to go deeper on that, we'll kind of do Q&A at the end. And by the way, I'm having way too much fun with ChatGPT's new image generator. Omar or David, have y'all played with this thing yet? The new image generator with
Yeah,
ChatGPT?
I think I generated an image for this deck with it, in fact.
Okay,
So
well, there you go. Making our lives easier. And let me know in the comments, my Zoolander fans out there, drop in the a good movie quote you got. It's funny. I think that's now like a classic. It's we're getting old, guys. Uh, But you got folks like Jensen Huang, CEO of NVIDIA, saying AI agents are likely a multi-trillion-dollar opportunity, and the age of AI agentics is here. And this guy's really smart, so there has to be some basis for this, right? And he obviously has a little bit of financial interest for this to come true. But regardless, this is a huge opportunity. And the pace of change is just insane, right? With any big opportunity, you're bound to have a ton of products, solutions, providers enter the market from entirely new solutions like Manus, positioning itself as this like general assistant to different frameworks, to people integrating it into their ecosystems like Databricks. And we're actually going to use Databricks in our POC later today. But regardless, it's just insanely hard to keep up with everything. And this trend's so big, you even have Dharmesh, the former CTO and founder of HubSpot. He's even built like an AI agent network where think of it as a professional network instead of for people, but for agents, where you can go out and essentially hire agents to do things. And this is kind of a new and novel concept, but you'll start to see more of this happen. But I think what's critical here is we got to start being able to separate hype from reality. So this technology is extremely new, extremely emergent, and we're still trying to figure things out. So like right now, we're seeing it execute small tasks, workflows, a lot of human in the loop still. But as time goes on, you're going to see it start to cover more dynamic workflows, and in some cases, entire job functions.
mm,
And the key thing I think for everybody on the call, it's the folks who are adopting and playing with this right now that are going to be the ones to reap the benefit the soonest. So, just like everybody in this lab, all you people here are going to be the ones that are reaping the benefit because you're engaged and interested in this new technology. And before I hand it over to Omar, I just set the goal for today. Like our goal is just to help demystify what AI agents actually are and give you a base understanding so you can start to put them to use. And with that, Omar, I'll shift it over to you to kind of give us the rundown on how you should think about agents, what they are, and then we'll kind of lead into the POC.
Thank you, Matt. That sounds great. I think one place to start is just a quick generative AI overview. So, in a way, agents are built on top of generative AI. We'll problematize that a little bit more and sort of unpack that. But if generative AI is the trend, then in a way, AI agents are really the tip of the iceberg here. It's when you integrate these agents together and create these multi-agentic systems that you can do some of the really amazing stuff that Matt was talking about. But we can't really get moving there unless we just understand generative AI. So we're all using it. We're all on ChatGPT. Some of us are on Claude. Some of us use it for various parts of our job offering. But I think it would be helpful to just put forth a definition that we like to use at Hatchworks. Generative AI is a class of AI that is designed to generate new content, text, images, video, code, etc., based on the data that it's trained on. Contrast this with discriminative AI or classical AI, as it had been done in the past, whose goal was less to generate new content as much as to make a prediction. And that prediction is, sure, a form of new content, but it's very small in scope. That new content that was previously generated was maybe a regression output or a classification or a label or an object detection or something like that. It's not generating the object, it's not generating the text, it's not so on. So that's really where generative AI breaks from the classical AI way of working. And part of what makes it so is that these systems are probabilistic and non-deterministic in nature. So whereas with a deterministic model, the way that AI had been done in the past, you're training what amounts to just a mathematical model. With generative AI, it's like you're playing a very sophisticated game of chance. And if you are sort of a Gen AI practitioner, you'll probably have heard of temperature, but there's a way to control the randomness embedded in generative AI because in certain use cases, you want to embrace the probabilistic side and the non-deterministic side because it builds those more robust systems that allow you to break with the past and build sort of beyond the boundaries of what had been possible so far.
I think
And
a big piece of this
I love
too,
this
like,
from Andre. Oh, go ahead, Matt.
well, I was just going to say, like this, the problem, it's such a big point because I think a lot of people think like, think of like an IVR system, like call support. In the past, you had to kind of define every edge case, right? If this, then that, every scenario. This is kind of that big unlocked where you don't have to go to that level of detail, and we'll get into it later, but I think that's a key component for folks to keep in mind where this is completely different than how you thought of automation in the past.
And I think that's the perfect segue. If we go to the next slide here, we also want to introduce the topic of automation because if agents are built on Gen AI, then it's really the field of automation that they're disrupting the most. And so we'll talk about a bit about the history of automation in a second, but really AI automation is the process of taking AI models and embedding them into processes that are automated. This approach goes beyond the rule-based automation that Matt was talking about. Think of like an IVR system where you have very specific if-then logic to embrace personalization, to embrace responsivity and customization. So if you think of the way you have a conversation, you go on tangents, you return to topics, you infer context from earlier to understand what came later. And based on context that surfaced later, you can understand what happened earlier. Traditional ML and traditional automation tools built on classical ML, but also built on RPA, were never able to do that. But generative AI is pushing the envelope on what's possible here. And so just for a few examples, imagine auto-responding to support tickets with contextual answers. A support ticket might come in and say, my car doesn't start. The response in the past will have just been to guide them through a specific flow. But over here, we have the responsiveness to get information as the conversation goes on to inform how we understand the past of the conversation. We carry all of that context forward to be more robust, more adaptive. And I think the next slide really paints this picture of the types of automation. So if we look at this trend starting from left and then moving to right, what we see is a transition from human encoded logic into human encoded goals, right? So when humans encode logic, they analyze the system, they analyze the workflow, and they come up with a very rigid set of steps as to how to do this workflow. As you go into this field of AI automation, and that second from the left, you start incorporating a few AI nodes within that generally human-defined workflow. And then as you move further and further, you're delegating more to the model. The model is able to tell you, here's how I would solve this problem. And it's able to sort of build the individual components that can solve that problem. So one example might be document processing. In the past, we would have taken a document, we would have done some standard searches on keywords, extracted those keywords, and so on. But now with the advent of agents, we're able to take those documents, understand the semantics, understand what they mean, extract tables if they do exist, and just bring a greater degree of flexibility so that the agent is telling us what it can and can't and shouldn't do in order to achieve the goal. So agentic AI agents, think goal-oriented, autonomous agents capable of self-improvement, not attached to a rigid process that stands to break.
Which these things aren't like, they're not human, but you start to see how they're being architected and the approach that is being taken. It's similar to how a human would operate in terms of having a goal that it's focused around, continuing to improve over time, those type of things. So that's where it gets interesting in the type of things you can start to do with it.
Yeah, and I think that's a great segue to talk about agents. So on the next slide, if you've watched The Matrix, you know agents, that's it, end of session. Thank you all so much for coming. No, but really, if we go to the next slide, we'll talk about what actually is an agent. The framework that we like to use is an agent is comprised of three things. You have the model, which is the LLM. This is essentially the brain of the agent. But then the agent needs to actually take actions. If the brain says, hey, do this or do that, the body has to follow suit. And that's sort of the orchestration layer. The orchestration layer is the thing that can take the brain's actions and then implement them. But the body is limited to the set of tools that it can use, right? And so that's where tools come in as little snippets of functionality that you can give the agent in order for it to achieve its goal. So if we want to put these three things together, what we end up with is AI agents or applications that attempt to achieve a goal by observing the world and acting upon it using the tools at their disposal. It's easier to understand this with an example. So let's take this one on this next slide of booking a flight from Austin to Zurich. So when the question comes in, we're able to recognize the intent because the LLM has really great natural language understanding capabilities, and it's able to reason about what a good plan of action should be. The first thought is to search for flights. With the tools that it has available, it has the ability to search for flights. And so the orchestration layer takes direction from the model and leverages the tool in order to do that. And it'll iterate through all of the other steps in the chain of thought before eventually giving the output back to the user. And again, this is the tip of the iceberg. Book a flight can be swapped in for virtually any kind of service request, any kind of customer facing thing, any knowledge base, or even any action, right? I want to book a flight involves making a change to the state of the world. You can easily say, I want to promote an employee. I want to send out this marketing campaign. I want to write this code. And the same process will happen where the agent will think, it'll use the tools to take actions, and then it'll modify the state of the world before then going back into that observance cycle.
Yeah, I think that's like the key thing for everybody to take away from this. Such a great simple breakdown. I dropped in the comments. There's a great white paper by Google that just does an amazing job of talking through some of this. But it's that access to tools that makes this completely different than just interacting with, say, ChatGPT or Claude, because it can take action, right? And this is such a good example with the tools it has here, the flights, the search, the code. But you think about it, as this proliferates, it's going to have access to lots of more tools as time goes on. It's kind of like the beginning of the App Store. There weren't very many apps in there, and then it just blew up as this marketplace in terms of things it could access. So that's a key, I think, differentiating point with agents is they can take action. They have autonomy in that sense.
Agents can take action and agents can reason for themselves, so they can determine
Yes.
what actions to take. So rather than just implement human logic, you can give agents your goals and recruit them as a planning partner with you. And so I think on the next slide, we really drive home this point that AI will shift the role of humans from doers to orchestrators. And we mean something pretty specific by that. So rather than just have this divide where the human is telling the bot, hey, here's what you need to do this one specific task, and then scaling up the number of tasks that the bot can do, we are expecting the users in the future, the humans, will be able to tell the agents, these are the problems that I'm looking to solve. These are the tools I have at my disposal. Collaborate with these other agents, which are each specialized in one or a small set of very specific things in order to take complex problems, break them down, and get them done. So we're really driving towards this future of a network of agents. So if you go to the next slide, Matt, we refer to this as the agent mesh, borrowing from software engineering and data architecture. But the idea is, rather than try to have one agent that can do everything really well, the correct way to scale is by having a series of small built-for-purpose agents optimized for the specific task at hand, that are aware of each other, that can communicate with each other, and that can break down complex problem into specific tasks that they can execute. Some of these agents will be orchestrators of others. So again, agents that call other agents and that trigger them to action. Other agents will have the more narrow scope of performing one bit of functionality, but together they have the ability to take down fairly complex problem statements. And again, as Matt was saying, we are just at the tip of the iceberg here. So I love the example of the Play Store, and I think on the next slide we make that point. We are just at the beginning of this disruption. When these major milestones happen in history, we take bounds and leaps as a society, and I think we're starting to see some of those broad social reverberations of this. We've got a lot of thought leadership on the sort of governance of AI, how to do AI safely, and what are the implications for teams. We won't get into those here today, but that's another side to always keep in mind, right? How is society being transformed by the advent of this technology and its proliferation?
I think this is the key thing too. It's almost like when a huge innovation or change comes into the world, you almost have to step back and think, what are the mental models that I need to have as I think about this new world that's not here yet, which is very difficult for I think a lot of folks to kind of comprehend. And it's back to this point here. When we think of like interacting with AI, most of us, it's just been I'm one-to-one in a synchronous way interacting with ChatGPT or Claude or something like that. But this is the way you got to think about it: is agents working with other agents, agents having very specific purposes and goals and what they're working on, where some may be kind of that orchestrator layer as well. And then things get asynchronous in nature. And it just, it's going to enable so much more than what we have today. And having that mental model in mind is powerful, because you're going to be able to kind of see a few steps ahead of everybody else.
Yeah, spot on. And I think one way that we're going to witness this social transformation is just the increasing role of agents in your organization, from first automating routine tasks to automating entire workflows, where you give them goals and have the agent figure out how to achieve those goals in the optimal way, to then entire job functions. We can speak about at Hatchworks, if there's interest in the Q&A, about some of our own initiatives on how we're trying to disrupt ourselves with AI agents. So we are a case study. We eat our own dog food, and we're sort of witnessing this firsthand. But for today's session, we are not going to talk about Hatchworks. We're going to be talking about Harmonia Health. Harmonia Health is a fictional company in the healthcare industry that provides patient care and patient follow-up. They have a telehealth platform that brings together doctors and clinicians and patients together. And Harmonia basically attempts to increase patient outcomes by adopting technology. So when the leaders at Harmonia Health started to learn about agents, they knew that they wanted to get on that technology wave. So the challenge that they identified within their org is, our clinical support team currently spent a lot of time working with patients in aftercare. They get a lot of questions whether a patient's symptom is related to their medication and whether they need to come in for a follow-up or not. Our clinical support team are not liable to provide this kind of information. They're not giving prescriptions. They're just giving sort of triage. So are we able to take that triage and have sort of a generative AI agent do RAG, which is retrieval augmented generation, to answer questions based on all of the based on the prescription history and based on each of the drugs' known side effects, and then take actions to schedule appointments where needed. And so our solution is a Databricks-based AI agent, which is, can we go back? Yeah, it's a Databricks-based AI agent stored and governed in the secure Databricks environment that autonomously performs patient prescription retrieval, semantic side effect search, evidence-grounded triage, and appointment coordination when necessary. Underpinning this is Mosaic AI tools, vector search, Delta Lake, and Unity Catalog, really the best in class from Databricks. I'll introduce the personas, and then I'll pass it off to our technical wizard, David Berrio, to talk about the architecture and sort of how we've gone about building this. So 4 personas over here: Alan, patient. Alan's a parent managing chronic conditions. Alan feels off after starting new medication and doesn't have the time to come into the doctor, balancing new child, balancing work, balancing life. They want clear guidance without immediately calling their doctor. Sophia, as a triage nurse, oversees this kind of triage workflow and post-treatment care for patients, and needs assurance that AI is going to follow safe evidence-based protocols so that she can provide more sensitive care to the people who need it the most. Dr. Tesabaji is the family doctor who Sophia would have normally sent Alan to. Dr. Tesabaji is also trying to provide only the dedicated care that they need and combat physician fatigue and have increasing degrees of auditability by seeing patients when they are most in need of it. And James, as a compliance officer for Harmonia Health, just wants to make sure that all AI agent processes are governed, auditable, follow successful HIPAA compliance and other regulatory requirements. So this is a quick workflow. This is a quick overview of the workflow that we're going to demonstrate. On the next slide, please. Alan will send some kind of outreach saying, my prescription has been making me feel woozy, and the Harmonia AI agent will be able to get the patient's prescription, query the side effects, get the appointment times, and then work with Alan to schedule an appointment that works best for them. Harmonia will be able to infer what to do based on the prompt that we've provided, the system prompt, which basically informs Harmonia AI of its goal, its tools, and the context that it needs. And then it's able to decide what to use, which tools to use, when to use them, and to actually execute on those tools in order to get the patient the outcome that he needs. So David, with that, I'll pass it off to you to talk about the architecture and then give us a demo of how we've built this.
Okay, thank you, Omar, for the great context and setting up the demo that we are building and presenting here today. So yeah, basically, as Omar mentioned, we're using Databricks as our provider for AI orchestration, for tools through Mosaic AI, and we are building this agent that Omar just described. So basically, we have Harmonia users on the left side. These users will interact with an AI gateway that Databricks will provide to us. And this gateway will give access through API to our agent orchestrator. And this orchestrator will have access to different tools, prompts, and LLMs. So we have different layers of access here. For example, going to the tools layer, we have different kind of tools in this demo, which is part of the interesting aspects of what we're going to show is that we can have tools that, for example, go to external systems through API connections. We have tools that can connect to vector search and perform a RAG workflow to retrieve information from documents of unstructured documents and basically provide responses based on the input from those documents. And we have tools that can access SQL databases through text to SQL processes, retrieve data from a data mart, and even write into that data mart to update any sort of information that we provide, as we will see in a moment. Again, we also have prompts. Basically, we'll have system prompts. We'll have prompts that are designed specifically to model the way that we want our LLM to react and to behave to different interactions. And we have different LLMs that Databricks provide to us that we can use to integrate or to use as the core engine of the whole agents, based on what Omar shared before. All of these technologies based on LLMs as a core. So I think given this general architecture of how we're going to solve the problem that Omar just shared to us, I want to go on and present the demo for this. Okay, so yeah, basically here we're just giving details of how each of these layers that we discussed is being provided by Databricks. So for the AI gateway, we have AI Mosaic, we'll have a Databricks serving, and we can use line graph integrated with that as an orchestrator. We can use Unity Catalog, which is built-in catalog from Databricks to basically store and streamline all the different tools that we will be using. We will have a Mosaic AI also as an LLM provider. We'll have DVX models to be able to handle different prompts, including system prompts. And basically, we are going to use DVX models and Delta Lakes to provide vector search capabilities and text to SQL capabilities as well. Also, Databricks is built on top of MLflow, so we will have access to MLflow experiments that are also going to be part of our Unity catalog, and we'll see all of these and how all of these elements come together in a moment in the demo.
That's
Thank
the
you,
beauty
David.
of
And one thing to call
Databricks,
out
right?
here is how much fits under the Databricks umbrella, right?
Yeah.
Under the Databricks umbrella, we've got the runtime for vector search, we've got our data storage, we've got our structured data in our data mart, which we can sort of interact with via text to SQL. Through Mosaic AI, we've got access to various LLMs, and then all of that governed through MLflow, experiments, Unity catalog, which is just awesome because it's all sort of plug and play. It's all right there for you. We'll take a look at sort of the low code interface. So if you're interested in building low code agents, stick around. We haven't called out some of the other things like notebooks, which just make the developer experience super easy and super streamlined. But David, maybe this is a great time to jump in and take a look at the demo.
Exactly.
Yeah, while he's pulling that up, like that's I think the biggest thing when you're working with AI is context, giving context to AI in terms of what you're working with, and that's the beauty of some of this is you can give it context in terms of the data that the AI needs to, make a decision.
Yeah, absolutely. Yeah, and what you just mentioned, Omar, is very interesting because Databricks provides a platform that deals with most of these things and put them available for us. So it's like we need just to put the pieces together to get to build an agent like what we are going to just show. So let's get started with the demo. Just confirm if you are seeing my Databricks console here.
Confirmed.
Okay, awesome. Okay, yeah, so as Omar mentioned, this is a demo about the power of agents and how Databricks supports agents and allow us to build this kind of tools. So it makes sense to start here where we are in the Databricks console. And we'll go and just show a little bit how the workspace is working. Second. Let me refresh here.
And while that's pulling up, we got a question from the audience.
Okay, yeah.
Omar, you may, or David, either one. But Steve Greenhow, he's talking about risk and mitigations when dealing with AI agents. He says, my experience is that anywhere between 15 to 30% of Gen AI output can be faulty, and 15 to 30% just doesn't fit my need. So lots of guidance and prompt work is required. My trust level isn't high. And this is like a very common thing in the industry right now is kind of that risk element, how accurate is it going to be? Curious, Omar or David, any thoughts on that?
Yeah, spot on. I mean, one thing that we like to say at Hatchworks is it's easy to do AI. It's hard to do it well. And having great policies and sort of systems in place to make sure that your prompt engineering is optimized, you are not hallucinating, and that you're regularly testing your data. Sorry, testing your output is crucial. MLflow within Databricks actually provides a lot of that out of the box, which is great. It allows you to build like a really robust testing suite. But we've got some collateral on our side around how we go about testing AI agents. So we'll drop that in the chat.
Okay. Awesome. Yeah, my Databricks console was frozen, but it's again working. So let's get back to the demo. So basically, I want to show how we set up a project like this. So I'm going to navigate to the workspace where Omar and I built the POC that we are presenting today. So we have Harmonia Health here. And yes, you can see here, I have a combination of different kind of files. So we have Python notebooks, we have MLflow experiments. As I mentioned before, Databricks is built on top of all ML capabilities on Databricks and are built on top of MLflow. So we have MLflow experiments here and much more. But we're not going to dig a lot with the structure here. I want for now to access our model. So there are two ways in which we can do this. So first one, we can go to the playground. And from the playground, we can access to different agents on the top. So right now I have our agent, our Harmonia Healthcare agent here, and we can start interacting with it this way. So as you can see, we got a response and we can start interacting and going through the whole workflow that Omar presented a moment ago. There's another way, which is basically going through serving. We have our agent served here, and we can open a review app. So I'm going to start off here before showing you some cool stuff that you can do in the playground. But let's start interacting with the agent on this screen first. So let's greet it. So he will say, hello, I'm Harmonia, your AI clinical triage assistant. It's nice to meet you. So as you can see, I'm impersonating Alan here, our user persona that Omar described before, and saying hello to the agent. So the agent will greet Alan. Adopting the character traits we list in our prompt engineering. In this case, it's going to act in a professional and courteous way. And well, recall that the primary purpose of this application is to help Alan, our patient, by giving him a way to triage any symptom he has. So I'm going to impersonate him again, and I'm going to tell the bot, hey, I just started my medication a few days ago. I feel woozy. So, okay, the agent will recognize at this point that Alan has not authenticated in the system, so it will need to trigger some sort of authentication. So for the purposes of this demo, we basically mocked up a two-factor authentication, and the agent in this point is asking us to provide a code that was sent through text message to us to a cell phone through the usage of a tool. In practice,
That's an
this will
important part too when you're working with healthcare data, personal information, and all of that, right? Having the
exactly
authentication in there and it not like bypassing that is another key piece.
exactly. Yeah, there's lots of compliance here. So, of course, in practice, this will even be more secure and sophisticated for different enterprise settings. But for the purpose of this demo, two-factor authentication in this way will work. So we'll provide the code that Alan received in this case to the chat. So now with this, the bot or our agent, our Harmonia agent, is going to be able to search for Alan ID and be able to authenticate. So we are waiting for that to happen. It will basically map. Yep.
As that's going, I think this is maybe a good chance to call out that we use sort of a lot of serverless infrastructure here within Databricks.
Yes.
So we do expect a lot of cold starts, hence the latency. Apologies for the delay, but maybe this is a good chance, Matt, to get to the question that we got in the chat. With regards to cybersecurity risks, prompt hijacking, jailbreaking, RAG poisoning, what are your thoughts regarding the risk from computer use agents? So this is a great question, and I would say maybe a few ways to tackle this. I'm going to focus in on computer use agents and focus in on web scraping just to get started with. The same technology that empowers the attack can empower the defense, right? So if you're thinking about this from like a cybersecurity attack vector standpoint, just as the technologies around, how to navigate browsers and scrape data without triggering any sort of logic that determines that you are a bot rather than a human, just as those technologies are advancing, so too is the sophistication of CAPTCHAs and other kinds of technology like that. So the defense is up to the task, and they're built on the same technology. That's not to say that everyone is using those defenses. So it's a game of arbitrage there right now, where computer use now is effectively like you can scrape so many websites that simply don't have that sophisticated logic built in. And then when regards to a chatbot itself, things like jailbreaking, rag poisoning, this is another attack vector, a slightly different one from what I'm describing. But that's where the AI governance that I was mentioning earlier comes so important. Yeah, exactly. You're clarifying that again, Philip. But yeah, this attack vector is really crucial, and that's where like really strong AI governance comes in and defenses. And like we can get into some more of the solutioning later on in FAQ, but this is where multi-agent systems really comes in, right? Because the goal of the multi-agent system is to have a guard and a judge in place so that nothing leaves the LLM that is potentially harmful. And basically that creates obstacles for this attack vector. David, I'll pass it back to you.
Okay, awesome. Yeah, okay, so at this point, now the agent has been able to identify Alan correctly. So it took that 6-digit code and mapped it with Alan's system ID, and now it's able to retrieve data about him. In this case, we want to retrieve his prescriptions, and actually he already did here. As you can see, since we are in the preview app window here, we are able to see the functions or the tools that the agent is executing. So it's executing get patient prescriptions via API, and it's getting a response. So basically, the agent is now telling us, hey, I've retrieved your current medication, which includes lisinopril, atorvastatin, and metformin. I hope I pronounced that correctly. And now it's prompting us that it would like to investigate whether those symptoms that we claim to have could be related to any of these medications. So we're going to confirm that we want to search. So yes, search for the side effects. And okay, and at this point, it's going to touch the tool that will do a vector search. And basically it will go through the documentation and will search if any of these medications has the side effect that the patient asked for. So what's great about this is that it's not only will derive the right query to use against the vector store, but it can ground its results and show that to us here. This gives us a chance to make sure everything is going right, to provide feedback and add in governance as needed. So it will show basically all the references that it used to provide the answer that we are getting here. And the good thing is that we have a feedback mechanism here where we can basically provide feedback to the agent to know whether the answer was helpful or it was not helpful at all. So it's a built-in mechanism for us to retrieve that information and measure how the agent is working. So
that's an important piece too, because as you start to scale a solution like that, having that feedback loop, whether it's internal feedback, internal tool, or external, it's just improving the solution over time, which is a really neat feature.
And with non-technical folks as well, right?
Exactly.
What I'm seeing over here is anyone can access this. Anyone is able to tweak and tune the model. And then the built-in sort of ML flow-based training loop allows for the model to improve with all of these iterations.
Exactly. And okay, so at this point, as we can see, the agent is telling us that, hey, okay, I found out that that you are feeling woozy or dizziness, it's a common side effect of lisinopril. So it's asking us, okay, I will recommend monitoring your symptoms and adjusting your daily activities to avoid any falls or injuries. If your symptoms persist, you can you can book an appointment with a healthcare provider. So I'm going to assume that Alan has been feeling this for quite a while now. So uh, I want to definitely ask for an appointment. So in this case, we are going to say yes. What are the
And as
availabilities?
David is typing that, I just want to reiterate a point that he made earlier, which is
Yep.
just look at the diversity of the tools, right? I mean, the first tool we got a two-factor authentication workflow. So that's API-based webhook using single sign-on. Totally outside of Databricks, totally outside of like the analytical realm. The second was getting the patient's prescription. That involves connecting to an ERP system via API. So that speaks REST API. And because it speaks REST API, I can connect anywhere on the internet to get the data that's required. The third thing we ended up getting, I think, after we got the prescription was the side effects using vector search. Again, taking in massive amounts of unstructured documents, chunking them, indexing, processing them, and then being able to take a user's utterance, right, which is I'm feeling woozy, and then chunk, index, and so on, and then use the same embedding model to then hit the vector search. All of that is sort of taken for granted over here. The end user does not need to know about any of it. It's just a streamlined experience across the various systems. And again, we see the same thing over here with getting an appointment time, connecting with an external scheduling system in order to get the correct appointment. So yeah, thank you, David. Please keep going.
Okay, yeah, no, that's a great point, Omar. Thanks for recalling that. Because yeah, we are using tools of different natures here, and that's completely transparent to the user. So at this point, the agent was able to retrieve the available options for appointment that we have. So it's telling us, hey, we have 3 available appointments times. So we have 9 a.m., 1:30, and 4:45. So let's say, hey, I want 9 a.m., please. Okay, so at this point, the agent is again going to execute the tool for scheduling the appointment. It's going to write the appointment time that we asked for, which is 9 a.m. And it will tell us, hey, your appointment has been scheduled for April 4, 2025 at 9 a.m. So yeah, at this point, we have gone through the whole workflow that we illustrated before, from basically getting to provide or basically tell what symptoms Alan was feeling to get to a point where we got an appointment with a healthcare provider.
That's awesome. And I think the other cool thing too, and David, let me know, am I good to take back over here in a second? Anything else you need to show?
Yeah. Actually,
Cool.
One thing to show. Yeah, one more thing to show.
Okay, cool. Yeah, go for it.
Yeah, one more things to show here. Yeah, so we're going to go back to the playground here. If you remember, this was the first option that we showed earlier to access our agent. And basically, that at that moment we added we entered here to agent sandbox Harmonia, which was already created. As you can see, it's a custom agent. But well, let's now try to understand how we can build an agent by ourselves. So let's return to our personas. So take James, our compliance officer. He's working with Sophia and the other triage nurses to create a training agent that help nurses quickly recognize and respond to side effects that appear in their patients. So James comes to the playground, which is where we currently are, for his low-code model building interface. He grabs the model of his choice. We have multiple options here that Databricks provides to us at this point. So in this case, let's go for a reasoning model, which is Cloud 3.7. So let's use this model. So basically, he grabs this model and he can select the tools from his existing marketplace. So these are tools that are built and deployed on Unity Catalog. So we can add a tool, and we will be able to see the different tools that we have at this point. So let's go to add search side effect tool. So let's add it. You can also add a system prompt here, which is basically what I mentioned before. These are like general instructions that the agent will follow through the whole interaction. So let's say something like you're a nurse, clinicians training assistant. Your job is to help level up front line workers by answering questions. So be polite and professional. Okay, so again, this is a prompt that the agent will follow through the whole interaction. And now let's just send a prompt to this agent. We can start interacting with it just as this, super simple. So let's ask, for example, which drug give the side effect of muscle pain, for example.
And while that's pulling up, David, we got a question. What would be the running cost of this, like kind of the per patient? And that's where it gets down to the cost per token of the model. So it depends whether you're using a more expensive model or not, but you're talking like fractions of, pennies in a sense. I don't know if there's a easy estimate,
yeah.
Omar or David on that, but compare that to human interaction, it's insane in terms of the difference.
Yeah, here's how I think about that. So recall how we introduced agents as having models, tools, and orchestration. You just sort of sum up the requests, the values of the cost of one request on all of these three things. It's pennies when it comes to the model. It's basic servers. So it's like the kind of API hit that you would use on like a regular software project for API. So again, also pennies. And then for the orchestration, similarly pennies, because that's basically just a runtime running LangChain. So also just like running an API. So an API that hits an LLM and that hits other APIs. And then, if you have a data store and a vector store that you need to maintain, that's actually a bit of a storage footprint. So that depends on the volume of data you have. But, I'd say most people will be able to get away with like queries that cost on average less than a cent.
Yeah, absolutely. And okay, so we have some results here. So as we can see, this agent was able to execute the tool for search side effects. So this is going to do some vector search and come up with some results. So based on the vector search, the drug name that matches better with muscle pain is atorvastatin. So it will come up with the response. So based on the search result, atorvastatin is associated with muscle pain as a side effect. So you saw it's extremely simple using the playground and all the tools that Databricks provide us to build an agent in a very simple way. We can again customize the different agents, so the different LLMs, and related to the question that was asked before, we have different pricings for different models. And yeah, you can select the tools from your marketplace and get to something like this very easily without having to write code.
Thank you so much, David.
Awesome.
So just to recap what we've seen today, we have seen an agent that we've built for Harmonia Health and two ways to access it. We've seen all of the tools that it can use within the Databricks ecosystem externally. They cover vector search, they cover read and write from third-party software as a service systems, and also Databricks itself. And we've also seen how you can get started building your own agents on top of Databricks. There's a lot of tools out there, as we'd mentioned. It's easy to feel overwhelmed, but here's a place to start. If you are a Databricks customer, or if you are looking to sort of make headway into AI and into AI and data, then here's one place to start. So Matt, I'll kick it back to you to.
No, this is awesome, y'all. And like Databricks, obviously, and the only solution you can do this with, they just make it super easy, so we like it. But I want to hit a couple things. We'll open up to Q&A. One thing too, like that was all text-based. You now have like voice agents and all kinds of things where you can just create these insanely cool experiences with these tools. I did want to mention, let's hit this first, actually. The winner of the Ray-Ban Meta Smart Glasses is, drum roll please, Tommy Walker. Tommy, you won it. You were very active in the chat, so I think you helped your chances there. And I think you had the best use case as determined by AI. So good job there. We'll be in contact with you to get those over to you. But congrats for that. And the other thing too, just for folks that attended, we got 5 slots we're opening up just this month. Frankly, so we can only do so many, but kind of like a free opportunity for as a thank you for joining. This is our AI Agent Opportunity Lab. Basically, it's a session where we sit with you and just help uncover the best use cases in your business for AI agents. Again, we're just doing 5 slots for this month. So if you are interested in this for your business, I think Andy, you're going to drop in the link for folks to do it, and we can share it after the fact as well. So if that is of interest, jump on it before the 5 go away. And then, yeah, start dropping in your questions. We'll do Q&A and we can stay a little bit longer as well. But we got the newsletter, the blog, tons of great content there. Some of the questions y'all were asking is actually answered in some of the content. We got Talking AI podcast, lots of really cool episodes going on there. You can find it on Apple, Spotify, YouTube. This will be on YouTube as well. And we're going to keep doing these labs. We enjoy doing them. I think I'm curious, Omar and David, obviously Databricks, there's a lot of just easy kind of no code functionality to build things in there, but there was obviously some coding to this. Like how long did it take you to build this thing? Because I'm sure you were using our GenDD methodology to build with AI as well. Like I think that may blow some people's minds as well on that side.
A few parts to this. So one, Databricks makes it really easy to use AI within their console. So a lot of your coding's within the Databricks console, and there are widgets almost everywhere you look for AI. Let's say that you want to write code in a cell of a notebook. If you're unfamiliar with a notebook, the closest thing I can say is like an Excel spreadsheet, right? Where you've got a series of cells. And you can very easily there write an AI snippet that says, write code for me that's going to create a vector search index. And it'll just do it, right? It won't get it right all at once. So you need to coach it. We talk a lot about garbage in, garbage out. That's one of our sort of GenDD methodologies here. So by bringing in our best practices and expertise on how to use these generative models, we're able to use Databricks' built-in tools to get accelerated as much as possible, and other tools as well. I mean, for some of this, we ended up using Cursor, ChatGPT for the storytelling, for the image generation, and so on. So GenDD at full play, and that probably saved 80%, 70% of the effort that we would have put in otherwise. So took it down from maybe 7 weeks to 1 week.
Yeah, that's crazy. All right, so Q&A and also State of AI report. We put this out every year. I think we're going to start doing this like quarterly just because stuff's changing so fast. But this is our 2025 State of AI report. Go to the QR code. You can grab it there as well. Let me take this down. What questions do we have? We hit the one, and y'all drop in questions as we go. Andy, help me out as well if there's some that are top of mind. Let's see. All right, is Databricks just a little more, it's a good question from Jimmy Watson. Is Databricks just a little more advanced, techier than N8N, or what is the main reason you all went with Databricks? And N8N is a great product too. We use that on some client projects as well. I'd say, and Omar and David, you're probably better positioned to answer this, but Databricks is definitely more of like an enterprise type of solution. N8N is, I'd say anyone could really, frankly, go in there and start using that today. But curious, y'all's thoughts.
So N8N's bread and butter, and N8N is a workflow orchestration company, right? And as a workflow orchestration company, they've incorporated AI to do agentic work. Databricks is an AI and data company. Part of one of the many services that they offer is workflow orchestration. And so in a way, what you can achieve with N8N, you can achieve on Databricks, but N8N makes it a lot easier with their sort of plug and play things for workflow management, right? So there's overlap between Databricks and N8N around workflow orchestration. Databricks caters towards more technical workflow orchestration for training pipelines and so on. And they've got really great AI gateway capabilities for modeling. N8N, on the other hand, caters for a more low-code interface that makes it easier to automate across multiple different systems. So less technical, more functional automation. We use them both.
Yeah.
In this case, we chose to use Databricks mostly because we wanted to show for a company who is using Databricks how they can start generating insights on their data, which lives in Databricks or which sort of in that umbrella.
And I'd say great place to get started with N8N if you just want to start learning. Like obviously come work with us. We'll build the thing for you. But I can't stress enough, like you as an individual, just go play daily. Just go play with something new. Such a great way to learn, get up to speed. And then like Omar said, AI is easy to do, hard to do well. When you get to the hard to do well part, come ping us. But another question on tool side, and then we get one on MCP. Any differences between Crew AI and Databricks? Another great question. Curious y'all's take on that. Crew AI is another great kind of framework and solution when it comes to agents.
So again, I think it's a very similar answer to sort of N8N, where Crew AI did not start off as like a data and analytics company, which Databricks does. So Crew AI will cover, again, there's overlap between Crew AI and Databricks. Crew AI is a lot closer, I would say, to maybe N8N than it is to Databricks, actually, where you can sort of build really complex workflows for multi-agent systems. They've got sort of drag and drop functionality for various tools out of the box. But it's not your one-stop shop for Databricks, right? So in a way, Crew AI would connect to Databricks to get data. I think the fundamental point here is Databricks is an AI and data company that does agents, right? Crew AI and Nathan are workflow orchestration companies that do agents. So they overlap in their ability to do agents. And for the purposes of the webinar that we gave today, you could have used either Crew, Nathan, or Databricks because we're operating in that overlap. So it's a totally fair question. But with Databricks, you get all of the other sort of data and AI stuff, right? The sort of classical AI, MLOps, and data lakehouse to store your data for enterprise scale analytics.
And if you don't know, just ask ChatGPT, right? So it's kind of like you're saying, they can be used together, but it's how you kind of architect it and whatnot. All right, MCP, we had a question there. How ingrained is MCP as part of the agentic stack? Still too new, and maybe, and I think we're at time, so folks got to drop. Thank you for joining. You can check this out on YouTube. Please share it with others. Love kind of building the awareness and just building these fun POCs. But maybe we chat a little on MCP and kind of like, what is it and the point of it? And this may be worth, I think, a future lab, just going deeper into MCP.
Yeah, I love this because I feel like a few months ago, Matt, you and I were like sort of speaking into the void around MCPs on the newsletter, and now it's sort of come.
Yeah, now it's the hot thing.
People are asking us about it. So I love it. I mean, we've been very bullish on MCP for a long time here. We use MCP for all kinds of things. Browser use can be solved for by MCP, file system use. So our generative AI practice leverages a lot of tools that are made available through the MCP. So to bring the question down to agents, I'd say it depends on what level of agents you're playing at. Nothing stops anyone from creating an MCP server right now. And there are so many pre-published MCP servers that you can spin up yourself that make it really easy to use MCP. So I think MCP was in a pilot POC phase months ago, but with OpenAI formally endorsing it as they had probably a month ago or so, and with just a steady stream of wins, I would say MCP is ready for people to start building plans around. Like, we don't hesitate to use the MCP on client projects when it's applicable because it's within the space, it's pretty firmly entrenched.
Awesome, good stuff. And I think just real quick before we wrap it up, if you want to go deeper on MCP, I'll just share this. We can drop it in the comments. Cursor, so one of the big tools we use, they have a good directory here, but you can actually go in and see the different MCPs that you can connect to with Cursor. So these are all different kinds of servers. You see like Stripe, GitHub, all different kinds of Google Ads. So there's all different kinds of things starting up. This is a good kind of reference and resource for that. I got my daughter visiting me if y'all can hear her. But I think that's any other questions we got in the chat. I think we may have hit it all. I think that's it, y'all. Well, great session, Omar and David. Thanks for joining us. Thank you, everybody who came and joined the lab. Please tell others about the lab. We'll have this up on YouTube. Share it. Tommy, I want to see the picture with the glasses on LinkedIn and social. Let's see you rocking those. But thank you, everybody. Have a good weekend.